Now, as we move along in these higher standards, one of the things that you would have noticed is that we would now be dealing with mostly, when we are measuring angles, we would mostly be dealing with a new unit, which is radians. And we will slowly do away with the old units which we have been using so far, and that is degrees. Okay, so we have to develop this habit of slowly start thinking in terms of radians. Okay, that the circle actually has 2 pi radians and those kind of things. We'll have to start developing this habit of thinking in radians instead of degrees, and this is what this sort of small lecture is all about, to familiarize ourselves with this concept of radian. Okay, so let us just start from very basic so that we are not scared of anything. So let's just start with very basic. Okay, and the idea is very simple. Okay, it is just that you have to familiarize you have just develop this habit, like I said. So let's start with this very basic. See, we have all seen this protractor, and that is what we are used to all our life, that this protractor, if you go around the circle measuring angles in degrees, then we will get all around this protractor. If we go all around it, we will get 360 degrees, right? So in a circle there are total of 360 degrees, and that is those degrees have been marked in this protractor, and so far we have been very used to that. And now suddenly what we are being told is that instead of measuring in terms of degrees, we will now measure in terms of angles in radians. It's one and the same thing. See, ideally there is no basically there is no difference between those. Instead of going 360 degrees, what we are actually saying, that instead of being 360 degrees in this entire circle, we have 2 pi radians. Okay, so that is what we are saying. Both are mathematically quantities. This is 360, the value is 360. Of course, pi, we know its value is around 3.14. So this would come out to be 6.28 radians. Okay, we will write short as rad. Okay, so this will come out to be 6.28. Okay, so both are mathematical quantities in the sense that both are numbers. But the only thing where students typically have a little bit of problem is understanding why we have to deal with this pi and they are not so comfortable, right? So 360 looks very convenient. We can divide it with lot of numbers and the answer comes out to be even. Suddenly we have this number pi, and then they think that, oh, what do I really do with it? It became so much more complicated for them. But that is just a mental block. Okay, it is not very complicated, especially if you are using calculators. What's the big deal? Instead of using 360, we'll just use 2 pi. There is no big deal. Okay, it is exactly the same if you think about it. It's just we are replacing from one number and going to another number. If you have calculators, there is no problem. And even in solving questions without calculators, there is no problem, because typically we can the answers, instead of expressing it in terms of full degrees, full numbers. Okay, if we are going in degrees, we will express them as full numbers. For example, 15 degree, we'll just write it. Here we will write it in the terms of a multiple of pi. That is what we will be doing. So m is any number, integer number. So we will typically express our answers in terms of pi only. So calculations do not really become that difficult. The only thing is that we have this factor of pi here. When we are dealing with radians, typically that factor comes in, and that creates this mental block. So we'll just explain the concept of radian in such a simple way that you will not be afraid of this thing, the new unit, anymore. Okay, it is just the mental block we'll try to remove. See, if you think about it, radians is actually a better quantity because there is some meaning behind its definition. What I did, I just took this protractor, this circle. Okay, this circle I took, and then I arbitrarily divided it into 360 degrees. Now, why do I divide it into 360 degrees? There is no real meaning. I could have chosen 1000 degrees. Why 360? There is no reason behind 360. The only reason is that 360 is a good number. It is very easy to divide 360 into various parts. So if you are eating pizzas and cakes, then this 360 actually makes sense, because then you can divide the circle into that many portions very easily, because 360 is divisible. It has lot of factors. But for mathematics and for physics, this radian, it makes sense because there is physical meaning. How is it defined? If I have a circle with radius r, and I take an arc of that circle which has the same length as the radius, right? So this arc length also is this arc is also how much? It is r. It has a length of r. Then the angle which this arc subtends at the center will be 1 radian. So there is a physical meaning behind this definition. We know that if I go around the entire circle, right? So if I go around the entire circle, how many such r's will I have? So I will have one more r here, one more r here. How much such r's will I have? Equal to the circumference of the circle, which is 2 pi r. So the angle, that entire 2 pi r would subtend here at the center would be equal to 2 pi. Okay. So notice how am I calculating radians? So if you think about it this way, radian, so angle, okay, angle in radian is equal to arc length divided by radius. Okay. So this is, I will not write, right? I will write the full thing, radius. Okay. So that is a good thing. There is some meaning behind this radian. Okay. It means something. So if I want to calculate radian, what I'll do is that this length is r and this radius is r. So this will be r by r, which is equal to 1 radian. If I go around the entire circumference, what will be the total arc length around the entire circumference? It will be 2 pi r divided by the radius r, and I will get the angle. But what will it be? 2 pi. So r and r will cancel. So there is some meaning behind this radian when we are expressing the angle in terms of radians, and that is why the second thing that we want to talk about today comes out. And the main thing here is that you should always think in terms of radians and not in terms of 360 degrees, and that is the most important thing. See, we already said that radians are most natural unit because there is some meaning behind it. The second important thing about radians is that if I express the angle x in terms of radians, then I can create the expansions, algebraic expansions of this cos, sine, all of these trigonometric functions. So they become nice algebraic expressions. Okay, they can be transformed to, not nice, but not so much nice, but at least they can be transformed to algebraic expressions approximately. Okay, and that comes in useful. The third important thing is in calculus, this becomes very, very important, and we'll just see this in a second. Okay, so if you're not familiar with calculus, even then you will be able to appreciate it. See, the thing is, there is this angle theta here, which is expressed in terms of radians. Okay, so theta is in terms of radians, mind it. Then this arc length, okay, and this thing is sine theta, and the radius has been taken as 1, but you can take this radius to be anything you want. Okay, if this radius is 1, then this length here would be equal to 1 sine theta, or just simply sine theta. This length here would be 1 cos theta, but we are not so much worried about this. We'll just focus on this 1 sine theta. Okay, and this theta is also in radians, and so this arc length will be equal to how much? This arc length will also be equal to theta if this theta is in radians. That is the only if this theta is in radians will this arc length be equal to theta. Notice that the radius of the circle is actually 1. Okay, so this will be equal to 1 into theta, which is just simply theta. So what would happen if this theta becomes closer and closer to 0? What would happen? See, as this theta becomes closer and closer to 0, what would happen? We'll just draw another diagram here. This theta becomes closer and closer to 0. This line of sine theta that we have drawn, will come closer and closer to this arc. It will become even more, the length of this sine theta, okay, will become even closer to this arc length of theta. So what does it mean? It means that as theta approaches 0, sine theta by theta will approach 1. Okay, and that is a very important result in calculus. So there are a number of advantages, and this result only holds true if theta is in radians. So there are a number of advantages of thinking in terms of radians. It is the very important kind of concept. It is very important for mathematics and especially physics, that you start doing away with degrees and now slowly and gradually come to radians. Okay, so now that we have talked about radians so much, there has to be a way we need to understand how to convert from one to another. So if you go around the full circle, we get 2 pi radians, that we already know. We also get 360 degrees. So those should be equal. Okay, so 2 pi radians, okay, is equal to 360 degrees. So that is one result. So therefore 1 radian will be equal to how much? 360 by 2 pi. and this will of course mean that it is 180 by pi. Okay, similarly we can also convert from degrees to radians, and 1 degree, oh sorry, this is not 5, excuse me, this is pi. Okay, so 1 degree, I don't know why I wrote 5 there. So so 1 degree is actually equal to, similarly we can also compute that, and that comes out to be pi by 180. Okay, so again, not very difficult, very simple results. Okay, so you should be able to remember these two results. Okay, now we'll do some numericals based on these two results. So that is the first numerical that we will be doing. And what is this? This numerical is saying that there is a circle with radius of 6 centimeter. Okay, so the radius of this circle is 6 centimeter, and now we have an arc whose length is 2 pi. So remember that these factors of 2 pi will come. Okay, but this, don't think about pi as something supernatural, something very esoteric. Okay, it is just a number. It is just a number which is approximately equal to 3.14. That is it. Okay, the pi is nothing. So then don't be afraid of pi. Okay, it is just like the pie that you eat. Okay, it is very tasty. Think about it that way. So there is a positive association. So it is 6 centimeter and this length is 2 pi, and we are being asked to find this angle theta. Very simple. So we know that angle theta in radians is equal to arc length divided by 6. Okay, so that is it. Okay, so in radians this would be our angle, the arc length, which is 2 pi centimeter. Okay, so units have to be same. So this is centimeter, this has to be centimeter. Okay, note the thing is that angles are always unitless, so we have to make sure that the two units, centimeter is divided by centimeters and nothing else. Okay, otherwise things would be wrong. So this is the quantity in terms of radians. So this is the angle that we have expressed in terms of radians. Now we already know that we want to convert now this radian to degrees. So either you can go straight away and use our formula that we have to convert the radian to degrees. So we will use this formula. It says that 1 radian is equal to 180 by pi. Okay, so we can go there. We can say that now we know that 1 radian is equal to 180 by pi. Therefore, theta radians will be equal to 2 pi by 6 into 180 by pi. And of course this pi and pi would cancel. This will be 30, and notice that how pi and pi actually got cancelled. So typically in your problems such things would only be provided. Okay, so we will be provided with numbers which cancel out. So pi either would cancel out, the pi's would cancel out, or you would be asked to express the answer in terms of pi only. So no additional problems come, and this is the answer, not in terms of radians but in terms of degrees. Okay, so theta degree is equal to 60 degrees. Okay, so both very simple. Okay, now we always ask you to remember this formula, okay, that we go from radian to degrees. But if you forget it for whatever reason, then remember that in the circle 2 pi is equal to 360. Okay, so 1 radian will be equal to 360 by 2 pi. So you can always go back to the basics and derive your formula. Okay, that's what I was trying to do here first, but then I thought that, oh, we have looked at it in the slide before, so just use it. I became lazy, but okay, it's not very difficult to go from here to here. Okay, so that is also fine. So if you don't remember the formula, go to basics and then do it. Now here are some common angles which have been given, and we are not asking you to memorize these at all. Okay, this is useless endeavor that you try to memorize it, the entire table. Okay, but what we will tell you is how do you do it in very simple way. How can you just do it in very simple way? See, the thing is 15 degrees is equal to pi by 12. Okay, so again we will go back to basics. We will see that 360 degrees is equal to 2 pi radians. We know that. So 1 degree is equal to 2 pi by 360. And then of course, if we have 15 degrees, that will be equal to 2 pi by 360 into 15. Okay, and if you solve it, this will come out to be 12. Okay, so this 15 to the 30, and then this will become 3, and 12 to the 36. So here we will have a factor of 3. Okay, so this will be 15 to the 30, so this will be 30, and 360, when we divide by 30, we get an answer of 12. So this comes out to be pi by 12. So 15 degrees, remember, is pi by 12. 30 degrees is pi by 6. Very simple, right? Because it has to be double of this. I am doubling this quantity, so this pi by 12 I multiply with 2, and I'll get pi by 6. Then from here on, we will simply use the we'll just use the factor, we'll use the multiple of 30. That is what we will use, and we'll come up with all these angles. Very simple. So just remember this one formula, that 15 degree is equal to pi by 12, 30 degree will become pi by 6, 60 degrees will become pi by 3. Okay, it will again become double, and so on and so forth. You can go on till 360 degrees or 330 degrees in this case. Similarly, for 15 degrees, then we say that 15 into 3 is 45. Okay, so we will use only even multiples here. Okay, so 15 into 3 is 45. So into 3 is 45. So here also we will multiply by 3. So this will become pi by 4. This is important, of course. Okay, and this is again important, 135, and 5 pi by 4. This is also very important, and then this is also very important. And here 180 degrees is pi. This is very important. Okay, so we have told you some of the important angles which often come, and we have also told you that if you remember this 15 and you remember the table of 15, then you can get the pi, the radian measure of all of these angles very easily, and that's quite a lot of angles. They will probably serve all your needs without remembering only by remembering this one value, that 15 degree is pi by 12 radians. That is it. So hopefully that the concepts are clear, and we are now ready to solve numericals, which we will of course solve in subsequent classes. Thank you.